Okay, lads, so geometry question 2010 on paper 2, all of it. The A part. You're given an isosceles triangle with one measurement in there. What you have to spot is that this is 48, and if that's 48, we'll then to find the missing angle. 180 minus 48 minus 48, 84 degrees. Fairly straightforward. I don't think there's anything too difficult about it. The B part 1, as I've said to you before on the videos, I can't actually do the construction because I can't put this pen into a compass, but what I will do is I'll show you roughly speaking how to do it, and remind you that when you're doing constructions you have to make sure that the arch lines are in there. Okay? So it's not a question that you can just line up the ruler. A good first step is always to draw a little sketch for yourselves. You're asked X, Y, Z. Try and make the bottom line the longest. It doesn't have to be that way, but I find that it does help. So you want this to be 10. You need X, Z to be 8 and 5. So going forward with it, you're going to rule out your 10 centimeters, and I'm going to do that here. Not shown. And as I've said to you before, a good idea is to mark off as accurately as you can the centimeter marks. So first thing we're going to do is we're going to draw the arch for XZ for 8. So what you'll do is, show this in red, you'll put your point down here, you'll count out from this point 8 spaces, and this will where the pencil is going to go. You'll draw your arch with the compass. It'll look like that. You'll flip it over. You want to draw the side YZ now. So you'll count out 5. Starting from here, remember. A lot of people sometimes make a little mistake and go to that point. So count out 5. This is where your pencil is going to go. Draw the arch. And where those two intersect, that's your third point. That's going to be your point Z. Join it with the ruler again, as take your time with it. And as I've said to you before, make sure that you join it to this point. A lot of people make the error and join it to that one there. And lads, to be perfectly honest with you, if I'm being quite fussy and being fussy with myself, I wouldn't even be happy with how I've drawn this, how I've joined that point. It's a little bit out. You get very little leeway when it comes to the marking of these. Probably it's usually only about plus or minus 1 millimeter. Okay, so if that was an exam for me and I wasn't working in pen, which obviously none of you should be, I would have rubbed that line out and drawn it again. Okay. I'll turn over, do a new page for the proof. Actually, I'll tell you, I'm not going to write the proof. The proof is in your book. You should know it at this stage. So I'm just going to jump on straight onto the C part. Alright, there's a lot going on with this. And before I mark in the letters and whatnot, I'm just going to put in the numbers. You're told this is 4, 5, and that's it. Except for this one out here, which you're told is 14. Obviously, lads, you have to read the information very carefully, and you're told that this line is parallel to that line. And once you see that, you should be thinking, okay, similar triangles. And as I've said to you, I think a good idea would be to turn the page around for this. What are you being asked to find? You're actually being asked to find this long length up here. If you have a look at the two triangles, and I'm just going to rotate them, you've got 4, 5, and then in the larger one, its counterpart, its similar one, you've got 14. We can call this x. So you can say, using the idea behind similar triangles, x over 5 is equal to 14 over 4. X is equal to 14 times 5 over 4. X is equal to 17.5. Of course, lads, what you were asked to do was find out what this length in here was. So if you take 5 away from the 17.5, you'll get 12.5. Now, out of interest, I'm just going to show you, and I'll put it in green, I'm just going to show you a different way to do it. Some of you, you know, it might help some of you. Now, I'm just drawing a very rough sketch, redraw of this, just with the pieces that I need. 5, how will I do it? Yeah, 4, 14, and I'm going to call this x. And lads, if I call what I'm looking for x, that means that this is 5 plus x or x plus 5. Okay? Using the exact same idea, so long side over short side, I'd end up with 5 plus x over 5 is equal to 14 over 4. 5 plus x is equal to 14 multiplied by 5 over 4. You can see that's going to be your 17.5. So x is equal to 17.5 minus 5, 12.5. It's just an alternative. If you're happy with the first way, that's fine. But some of you, it's just an alternative. It's another option. Okay, so we're going to move forward. Last part of the question. Okay, so again I'm just going to draw the sketch out. Not great, but it'll do. 5, 4, and let's leave that for a second. You're told, you know already that this line is equal to that line, that they're parallel, sorry, not equal, that they're parallel, and that's grand. But in the next part of the question then, you're told that these two lines are parallel. And then they ask you to work with two triangles. They ask you to work with this triangle here, which is ADE, and they also ask you to work with this triangle here, which is DCF. Maybe I'll put, can you see that right? Is that okay? So let's just fill in whatever information we have here. You're told that this length here is 14, so this has to be 10, and we now also know that this is 12.5, and what we're asked to do is find the area of the triangle, one triangle over another. So the area of a triangle, and you're given a little hint, you're told area is equal to a half AB sine C, and that's from your trigonometry. And that's a real example of how they're starting to mix up the different topics in recent years. Now if I take this triangle down here, let's have a look at it. I've got 5 and I've got 4. And from your work on trigonometry, what you know is you have to have that angle in there, and I'm going to call it C. And now I'm going to take out this triangle here. It's a little bit bigger. And I know that this is 10. I want to work with that angle, but I'm missing a length. So if you go back up to the diagram here, you know that this length here is 12.5. But if opposite sides are parallel, well then it's either a rhombus or it's a parallelogram. But either which way, you can say that the opposite sides are equal. So this side is actually 12.5 here as well. So if that's 12.5, well then this is 12.5. And now I've got something to work with. Now you've noticed I've labelled both of the angles C and C. Why can I do something like that? Well, it's kind of hard to see. I'll put it in red for you. See the F? Now it's not our traditional F, you know, that looks like that. It is a very kind of a awkward looking F, but nonetheless you've got two parallel lines meeting what you could call a transversal, or meeting another line. So that means that those two angles, they're equal because they're corresponding. Okay? That's why I called this C and this C down here. So working with the two triangles, the area of this triangle is a half 4 by 5 by the sine of C. This triangle down here is a half 10 by 12.5 excuse me, by the sine of C. Putting one triangle over another, a half, I suppose I better write this out, triangle ADE over triangle DCF. It's a half 20 sine C over a half 125 sine C. Just work it down, take your time. So 10 sine C over 62.5, so 62.5 sine C. Sine C over sine C, well I know that the angles are the same, so I can cancel them. And then just put, it does say as a fraction in its simplest form. So I would, in your calculators, just 10 over 62.5, let the calculator do that little bit of work for you, 4 over 25. You're finished. As questions go, it's not that difficult, but there's an awful lot that you need to see, and it's a question that there's a huge amount going on in.